our next speaker is Ivan Sánchez from Zyte. So Ivan, come on up and we'll get started. And then this will be our last open session for the afternoon portion of this event. And then afterwards we'll have a short break and then we'll get into a panel discussion as well. So let's just switch over for Ivan here and then we'll get started. Thank you. All right, give it up for Ivan, please.
Yeah, hi everyone. I'm Ivan, and I'm gonna talk to you about Zyte in general. What are we doing in web data extraction and in web scraping, and especially using the latest trends and especially large language models. So I'm a data scientist in Zyte. I've had the privilege to work for Zyte already for 3 years that have been very, very good in terms of how much I've learned. And fortunately, I've had the chance to work in research and development and using the latest trends to be able to push forward into the data scraping and also building a product that works using this kind of technologies. So it has been a very, very interesting path in my career. So what do we do in Zyte? So we actually do a lot of stuff. I'm mainly doing data extraction part, but that's not the only thing that Zyte does. So Zyte also does crawling and also manages the access. So for example, when you get banned or when you have a problem trying to access a page because you are geographically prohibited to access from your location, we give some kind of systems for anti-ban or rotating proxies, or also what it's called proxies, residential proxies that actually allows you to access, like if you were a normal person, that kind of evades the kind of bans that you would get for using proxies that are detected by the anti-proxy systems. And we also do captcha solving. We're investigating also in captcha solving technologies, also using LLMs. That's a very interesting part. We also do custom extraction project, which is more like a one-time project that we deliver data with. So we actually have people there working, creating what we call scrapy cloud spiders, which is basically code that runs some data extraction. It can be very custom, and then we just sell the code. And we actually do much more. Like actually, one of the most important things that I found is the legal and the compliance that you have to follow when you work with data and when you scrape data. And we actually, one of the good things in Zyte is that all the stuff that we do has to pass some kind of legal compliance. So it's kind of built in the whole system, and that's another good thing that we do. So I think it's pretty obvious at this point that LLMs are revolutionizing not only how we extract web data, but everything, really, like any problem you can think of that, for example, consultancy firms would pay millions to work on, like, for example, some text classification, name and entity recognition, relationship extraction, you name it, like any kind of problems that would require data scientists there working and training a model. Right now it's trivial with large language models, and LLMs are making trivial a lot of these problems. And data extraction is no different, right? And that's the particular kind of problem that I'm focusing on. So what I'm gonna tell you here is a little bit of the trip that we are doing in Zyte, how we started doing data extraction and how we are adapting ourselves to use LLMs to empower even more what we can do. Also, I'm gonna go also to the cost and feasibility, especially because one of the ways that we're using LLMs to extract data is using the LLM for every page, which is very expensive. which brings me to the next one, which is what we're working in now, which is code generation using LLMs, which is a more complex problem, but will be much, much cheaper. And at the end, I will go through agents and some caveats that are kind of arising right now, that agents are getting more and more popular. So before large language models, what we had and what we have right now are what we call standard schema. So this is like a way we defined the data will be returned to you when scraping for a particular, let's say, product. You want to scrape for product, so we have a standard schema for product that will basically give you the data for a product, which includes the price, the description of the product. There are like 25 fields, and you will generally get the data in the same format always. To work with this, we have like a model under the hood for each one of the schemas. And how it works is basically it's a deep neural network that for each one of the bounding boxes, which are the nodes of the DOM tree of the HTML, it classifies it into if it's like a price, like the description, and then we do some kind of post-processing to that. And at the end, we have like the standard data that we will give back to you. So it basically works with a machine learning model that has been trained with actual data that we had people annotate into that kind of standard schema. And we have been running these kind of standard schemas already for several years. This was born, I think, in 2017, and it works pretty well for the use cases. But we have a long tail of customers that have, apart from this kind of data that gets returned with these standard schemas, they usually have a very specific thing or need they want. Like they want a product data, but also they would like to know, and this is actually a real use case that we had, and this was from food products. They wanted to know certain ingredients, if they were present in the food product or not. In this case, I'm just putting an example of a salad, and we will see later in general how we solving this with LLMs, but let's say that a customer wants to know whether a food product contains tomato or kale or whatever ingredient. This kind of sounds easy in some sense, but if you think about it, how do you actually write a scraper to give you this? It's kind of very hard to do in a general way, right? Because you will have to parse, maybe you try to do some rules and then you see that some rules fail, so it's not so straightforward. And we can go beyond, and I'm going to show you another example that we actually had customer B that wants to know if the delivery of a product is free or not. This may sound easy because most of the web pages have some text that says free delivery or the delivery of this product is free. But, you know, it's the edge cases where you want the LLM to be there so that you can extract these kind of edge cases with a high probability that you will be right. And this is a very interesting edge case that I found when investigating this problem. Yeah, probably you can't see it, but the page says that there's a free delivery for orders above $100, and the product is $254. So this is like some kind of dynamic understanding you need to have per page, right? To kind of understand if the product is free. So LLMs are very good at this. So probably any LLM right now in the market can very easily understand and solve this kind of problem. And the way to do this is a very straightforward way, is just using the LLM to ask the question, right? So here in this first approach that we already have implemented and integrated would be using some kind of, so the user would send a URL and the schema that is requesting a data extraction. So with this schema, the user is basically saying what he wants to extract. And then with the URL, it would go to a browser you would obtain the HTML, which can be with the render page, with a more or less information depending on some parameters of the browser. And then you would generally go through some kind of simplification pipeline. And this is because you will be using the LLM for each one, so it's better to go simple and also so that it will be cheaper. And at the end, the LLM will just spit out the extracted data. So it's very straightforward, right? Probably a lot of you have also tried this. And this is an internal demo that we have, that we use with our models and also closed source models to see how they behave to these kind of queries. So yeah, I'm sorry because it probably can't be read, but it's basically trying to solve this problem from customer B. And it's actually the same page, and I'm asking for two, what we call custom attributes, which you can ask for basically anything. And the two custom attributes that I asked our model, this is our model, which is a Llama 3.2 8B that we fine-tuned for the data extraction task. And I'm asking for a kind of analysis of the page. This is like a chain of thought, trying to evoke chain of thought, so that it will try to understand first the page and if the delivery is free or not and why. And at the end, this is generally not important. This is just like for debugging, but also, I mean, not important for the output, but it's important for the model to get it right, like the next one, which is whether the delivery is free or not, depending on that analysis. So I would generally use the second one as in general, when I get all the data. And the first one can be also useful for debugging and seeing how the model understands the page or what information it has access to. And as I said, this is already integrated in Zyte API. So it's as simple as calling Zyte API. So the good thing about Zyte API is that everything is under the same API. It's unified. So what this does, easy for you, it's not so much the extraction part with the LLM, because anyone can do that, right? You can just use, I don't know, Selenium or whatever to download the HTML and do a pipeline to ChatGPT and get the answer. Anyone can do this. But the good thing with Zyte API is that this kind of extraction, custom extraction, is coupled together with everything else. So we will have the anti-ban that can allow you to access any page, depending on even geolocation, restricted or whatever. And it can also scale in a way that we already have prepared for that. For example, if you want to do scraping and at the same time extraction, that's where you would use this kind of, so you can use the same in Scrapy Cloud, which would also give you the capacity of doing the scraping and also doing the custom attribute extraction for each one of the pages. So it's all integrated. That's the fun part. And actually there's here a collab, yeah, and my bad, I should have put here some kind of QR, but it's a collab where you can experiment and try these by yourself, and you can do some kind of analysis or whatever using that, and it's completely free because you get like a $5 free usage when you register. So obviously, when you use the LLM for every page, that's going to be expensive, and that's pretty obvious. So there are several optimization strategies that you can follow, and most of them are already kind of, a lot of people have already done these, but what if you use them all together? And this is only important if you're running your own model, right? So the obvious one would be using a smaller model. So the latest closed source model we know the number of parameters of is ChatGPT 3.5, which is 165. We're using a fine-tuned 8B, which is more than 20 times less number of parameters. This is clearly an improvement in the computation that you actually need to run it. And the fact that it has been fine-tuned makes it no worse than, for example, ChatGPT 3.5. Also, one pretty obvious way of improving the cost is only sending the essential text to the large language model. So there are several ways you can truncate or simplify the HTML before sending it, right? So what we are doing here is, so I was talking about standard schemas. So one of the, for example, if you're extracting a product, what we are sending to the LLM is not the whole page. It's just like a relevant part of the page that our model detected. So one of the classes that we have under the hood for this model, for the product model, for example, is the node in the HTML that contains all the information. And this is what we're sending to the LLM, and we found that the cost gets reduced a lot, almost by 50% when using the whole HTML. Sometimes much, much more, depends on the use case. And another, maybe not such obvious way to improve the cost is batch processing on the one hand and context reuse on the other. Each one solves like one kind of problem. So for example, when you write something to ChatGPT, two things happen. First, there's like the pre-fill phase where for the whole input that you typed gets computed in parallel. So that's compute bound in the CPU. So the CPU is compute bound, meaning that it's the compute that it's being the bottleneck there. And after that, it processes this pre-fill phase. It comes the auto-regressive decoding part, which is when it starts spitting each one of the tokens. And this part is not compute bound, but it's memory bound. It's bandwidth, memory bandwidth bound. So the batch processing solves the memory bandwidth limit, or more like bottleneck. Another thing that would solve that kind of bottleneck would be speculative decoding that has been also used in the past. And we were using it at some point, but since we switched to batch processing, we don't really benefit so much from speculative decoding because we're already using the whole bandwidth, so it's not so important. And context reuse would improve the compute bound in the pre-fill phase. And with this, we have managed to make LLM extraction from each page super, super cheap, but still it's very, very expensive if you think about it in the broader terms. Like, for example, we generally takes half a cent per page in many cases to do LLM extraction. But if you think about 1 million pages, that's 5,000, right? So that's just too much for all the customers to pay. In general, they won't want to pay so much to do some kind of extraction. So another approach that we're investigating now and we're implementing is how to use the LLM to run the code generation that will be the one extracting the code. So this schema can be a little bit daunting, and the idea under it, it's not so hard. What it's hard is to implement it and execute it. But the idea is pretty simple. You have, let's say, 5, 6 URLs that can serve as examples to extract data, and then you would use the LLM and ask the LLM, hey, generate code to extract this kind of data from these HTMLs. And then it would generate the code, you would store this code somewhere in a database, in some Git, and then you would, let's say for many, many more pages, you would generally run this code and obtain results. So here, the most interesting part is the code generation, obviously, and how to make it so that it will self-heal over time. For example, when the page changes, you have to detect that, so that's a challenge. You also have to understand when you have reached a code that works. That's also non-trivial. And one part that's also very important is how you make it safe and against attacks. So generally, it's a good practice to sandbox the code that you're going to run in a way that it cannot really interact with anything that you won't allow it to. And at the end, I will show like a lot of different ways that can be exploited in the agents ecosystem that can be potentially harmful for every company that uses. And this is just a sneak peek of a tool that we're working in. That this is code generated by the LLM, and this would be just to extract the main image of a product. Unfortunately, I can't show more than this, but I think it's taking pretty good shape, and I'm super excited for what's coming. And we have a lot of different internal usage already for this. But before we can actually make this public, we have to polish a lot of edges, but it's already working, and it's very interesting to see it working and deliver. This is not really substituting the people that are working in the code, but it's reducing probably 80% of the time they're taking to write these. So that's already a win. And then another approach would be something hybrid. So even if you're generating code with the LLM, probably both of the cases that I showed you wouldn't be able to be extracted even if the LLM generates like a perfect code, because it can be very hard to parse, and some cases can be dynamic and be or sometimes you need some analysis or some summary, for example, for an article. This doesn't matter how you write the code, right? That you can't obtain it in any way. So what about a hybrid approach that you would generate code to select the main parts that are relevant, but then this code is allowed to call the LLM as well. So for example, if you would need, let's say for the ingredients case, where I want to know if, let's say a product that is food contains tomato, how this would work would basically be that the LLM has to understand in what part of the page are the ingredients, and it would take this using code, but then the code will call the LLM to know whether this ingredient is part of this list. And we're still not there, but that would be like the most flexible and at the same time cheaper way to do any kind of data extraction you can imagine, and even data generation. That can be, for example, as I said, in these generating summaries or doing some other kind of generative kind of data extraction that you would need. So about the latest technologies for LLM code generation, I find myself like pivoting models every 2 months because something new comes and I want to try it and I want to see how powerful it is. How many of you have tried Gemini 2.5 Pro? And how many of you that have tried it have found it to be, how to say, like very superior to, well, what we had then was 03, we already have 04. I mean, we can see that OpenAI is trying to, release stuff now that Gemini 2.5 Pro is out. But how many of you have found Gemini 2.5 Pro superior? The thing is that for most tasks, you generally, ChatGPT already does a very good job, right? And for most tasks, you can't see the difference. But there are tasks, and actually, this is something I found like 3 weeks ago, 1 month, when Gemini 2.5 Pro came out, that excels compared with all three. And this also comes thanks to the long context that it gives you, which is 1 million. We still don't have this in OpenAI, as far as I understand. And it's really a game changer for some specific things that we're working on. And as models get more powerful and agents become more of a thing, that we see that it's like racing in general. Things like React prompting, it's becoming more useful. And what is React prompting? So here's the paper. It's kind of, it's a basic idea. It's similar to chain of thought, but between the thoughts, like it thinks first. This is the re part, which is the reasoning, and then the act, which is calling some tool and doing something. right? So it can think, analyze some text, or the question, think itself, what do I have to look for, and what tool do I have to use? Then it uses the tool, and then it kind of, again, thinks and reasons with the results on that, and it does this in a loop. This paper, I think it's from 2023, so it's already, let's say, kind of old, so to speak, but it's gaining relevance because agents and, in general, LLMs are becoming more and more powerful, and the more powerful they get, even with longer context, the more relevant this gets, because it can do this more and more and more. And about protocols, well, we already heard a lot today about MCPs, A2A. I have to say that I'm very skeptical about MCPs. This is probably a very hot take, but, well, we can discuss this later, but I still don't really, I mean, I can see and understand the purpose of MCPs, but as I said, I keep myself skeptical whether this will be used for a long time. Maybe I'm completely wrong, but I don't know. I think that there's a very high chance that they will get deprecated at some point. But obviously, right now, they have a purpose, and they are there, and they're useful. Not sure for how much time. And yeah, I mean, models getting more and more powerful means that they can do self-discovery and self-debugging. And I will actually show you something super interesting that I found using Gemini 2.5 Pro. And I don't get paid by Google for saying this. It's just that this model really shocked me in what it can do. And let me show you a case study that I was working on when trying to develop, or more like refactor, the way we're doing the code generation. So we already have a pipeline that does code generation in some way. It has several LLM calls doing this and that, creating a test, and then try to generate code, see if it passes the test, and more details. But when I saw this new model from Google, I was like, can we do it simpler? And from what I saw, it's kind of really looks like this model can already do so many things so well that we can probably simplify the pipeline that we have. So the case study, let's think about product pages. And let's say I want to extract the images from a product. So the straightforward way would be to look for the HTML elements and see like the carousel or the thumbnails, and just like as you can see here, they will be there, right? And you can extract them from there. But what if you want the images that are in highest resolution? So maybe the thumbnail ones are not the ones you want, right? So you would generally want to explore all the different ways you can extract this information from the page. So I can tell you already that these ones are not the highest resolution ones. The highest resolution ones for this particular use case are in the JSON. In some JSON that you can find here, it's inside a script and a node, and it actually has to be parsed in a specific way. And I actually found this pretty common in a lot of pages. I don't really understand so much why it's done like this. I think it's some kind of metadata information that gets run in some scripts, but the JSON data is there, and generally you would want to extract the data from there because it's like more structured format, and the real information that gets executed when you click a button, and for example, if you click one of these thumbnails and it loads it there, it's taking the information from that JSON. So you want the data from that JSON. But the problem is to understand in what cases the information is in the JSON, the one you want, and in which cases the information you want is only in the HTML. You know, it's a very complex case. And generally, if you would try to, and one of the things that we were doing is removing the scripts to make the HTML smaller to do code generation because of the context window. And you have probably experienced that if you give a lot of context, like input to the LLM, the reasoning capacity and the code generation capacity, and in general, the capacity of the LLM goes down. So that's also important to try to reduce as much the problem that you're trying to solve, the context, so that it will be much higher quality. So here, what I tried with Gemini is to do a kind of a two-step solution. This is similar to this React part, where I would first ask the LLM to analyze where it can extract the data from, and then do the actual coding part. So this would be like the first step, the analysis. And I would do this for maybe 4 or 5 pages. And it gives a very, very detailed analysis of where from it can extract the information and how. And then I just gather the analysis, and for example, I will have 5 analyses from 5 different pages from the same domain. And I would just ask, create some code that would extract data just given this analysis. So I'm not using the HTML anymore, I'm just using the analysis. There's an obvious problem with this, which is that very rarely the LLM will get it right in the first iteration, because it doesn't have context. It doesn't have the entire HTML to understand. And by the way, yeah, I forgot to say, sorry. I'm passing the whole HTML without any cleaning to the analysis. And most of the HTMLs are like 400,000 tokens up to 800,000 tokens, so it's very expensive. But I found Gemini to be able to do this very well, even if the input is so long, and that's the game changer for me. So once I have the analysis, I ask, can you create code to extract the data given by this analysis? And I also ask him, like him, her, they, them, to put print statements in the code that it's generated. And this is a very simple idea. Like, it's so simple, but it's so powerful, because it allows the model to discover dynamically the environment that it's working on. So I'm asking, create code to extract from this analysis, but put print statements for you. I will run the code that you give me, and I will give you the standard output, or if any exception happened when trying to run the code, and all the logging that you will be putting in the code, and also what the code extracts. I will give this back to you. And so put print statements to try to figure out what you need. So you can see here, there are like print statements. This is completely automatically generated code to extract the images from a product. And this is what I give back. This is like the feedback. So I run the code that it gives me. Probably the first one won't work, but returning to the LLM what in the standard output gave me and the extraction is very, very good information for the LLM to understand what went wrong and how it can iteratively. So I do this over and over and over, and it understands what it has to add to explore even more the problem. So this would be very, very similar to what we would do generally. Like, I find myself trying something, to code something, and it doesn't work, gives me some error, and copying and pasting it to ChatGPT and getting some answer. So this is basically the same, but in an automatic way. So I will give the LLM the feedback, and it would just generate the code again. That would probably try something else, maybe put some other print statements. In this case, we found something super interesting. So to find these images in the JSON, in every iteration, it was trying to print the keys from the JSON. So it was a very nested data structure in this JSON. It was very complex. It had more than 200 keys and, I don't know, like 4 or 5 levels of how nested it was. But doing this kind of self-discovery, thanks to the print statements, enabled it to reach the solution to this to extract this data. And I mean, this is very simple also to achieve. I just said in the first prompt that if the code, like if the feedback that I'm giving, it understands that the code that it generated, it extracted the correct data, then just put this kind of tag to tell me that it's already finished. So that would be like a stop condition. And this is like the final extraction. This is 2 images only, but it extracted 28. And yeah, they were the correct ones, and they were the highest resolution ones. And it took 8 code iterations. So this is like the length of the chat session minus the last one, which doesn't really give me any code. It's just the acknowledgement that we reached the solution. So that's quite a lot. I mean, this is kind of one of the hardest cases, probably the hardest that I found, and it got it right. So that's super interesting. But probably for easier cases, just we'll need 2 or 3 iterations. So I don't know how, can you tell me 5 minutes? Yeah, thanks. But the thing with agents is that as they get more powerful and there are more uses to the agents, and as new possibilities with agents unlock, there are new challenges that are arising, and most of them are, whoops. What's happening? So there are new challenges that arise, and most of them are, the problems that are arising are like they can be exploited and they can be used against, and they can attack using these kind of agents, especially when you give the agents capacity of running tools. So one of the kind of interesting problems that you can run with agents is called in-context reward hacking. This is not a potential issue in the sense that you will get attacked, but it's more like the agent cheating to get into the solution, but giving you a bad solution. And actually, so let me give you 2 examples. One would be, imagine if you have an agent to try to maximize Twitter engagement in the tweets. So that's a valid optimization policy, right? Like I want to make my content more engaging. But maybe what it can do to maximize the engagement is create more toxic content. So that would be an undesired way of optimizing my policy that I don't want. So it's kind of cheating to do that. I don't really want the LLM to go into that way to maximize the engagement. And this happened to us, I mean, not the Twitter example, but the in-context reward hacking happened to us for code generation. And it was very interesting to see. So sometimes when the test that we would create for the LLM that has to pass when doing code generation iterations, they would be impossible to reach with a, let's say, normal code generation. So it would basically cheat itself and say, okay, if the product had these keywords, I would do this in particular. If the product would have these other keywords, I would do this. And it would do this just basically to pass the 4 or 5 tests that I was giving it. Definitely this is not what I want because it wouldn't generalize well. But it was very interesting to see this is already kind of solved in some way, and with this kind of other way of doing it that I presented to you would be better, and we would avoid this kind of problem. But it was interesting to see what they mentioned in this paper actually happening to us. And yeah, other problems that can happen with agents are memory or RAG-based poisoning, which is basically you can control the prompt that the user gives you, but if the user is injecting something malicious in the web that your agent will access to, maybe that's not so controlled. or maybe you don't really have so much capacity on really checking that. And another interesting case is the improper tool use. And in the paper, they show a super interesting example which uses, let's say you have a prompt already written by someone, and you would use this prompt, for example, in ChatGPT, you can actually go to custom ChatGPTs, right, where they will already have some kind of internal prompt. I don't think you can see that internal prompt. And then within that prompt, you can write what you want. So, for example, there could be ChatGPT specifically to write a CV for you, and then you would write your personal information there along with this prompt that someone wrote for you. So this prompt, in the paper they show that it can have some prompt injection, which actually makes the model call to a URL that will dump the personal information to a server when trying to run this HTML call and trying to use the browser. And so it's a very interesting way to see how just allowing the LLM to use the browser to look for information, it's already giving you the possibility of getting attacked, and your information that you put in the prompt, exposed and filtered. And obviously there are like ethical and legal problems that comes with agents, but also like web scraping, which would be like respecting the robots or the terms of service of the web page. So yes, a conclusion, it's obvious that LLMs are revolutionizing web data extraction and allowing us to do a lot of stuff that wasn't possible before. And we're actually at Zyte working very, very hard to make the most of them, but also in a way that will allow us to give the best kind of results in the cheapest way possible. And the best approach really depends on the specific needs. So it's not the same if you need to extract information from, for example, 5 domains, and from these 5 domains, 200 pages, you can use an LLM for that. But if, for example, you're trying to scrape Amazon, which is huge, you would probably go better with a code generation solution. And in general, agents really show great potential, but need to be used cautiously, because they can have a lot of issues, especially when you let them running without any kind of surveillance. Yeah, thank you. Any question?
Hi, thanks for the presentation. I have a question to you regarding the extraction with LLMs. So you mentioned that you fine-tune your own model, right? And it's quite a small model. When I experimenting, when I using LLM for extraction from any documents, what I observed is that smaller models, they tend to lose the data if the output is longer than, let's say, 5 data points. Did you have the same issue with your small models, and how did you solve it?
Yes, definitely. With smaller models, the more kind of attributes that you want to extract and the more you generate becomes harder problem, and it will usually get lost in the process. So this is actually a problem that still kind of happens. The way we tried to solve it to the better extent is, one, we don't really allow too many attributes to be extracted using this to kind of limit what the user can do, because that's a limitation of the technology and it's there. And the other one is basically doing more and more training data, adding more training data that is actually asking for so many things to be extracted. I mean, this will always improve up to an extent the LLM capacity to do this.
So did the fine-tuning really helped? Did it really worked for these small models?
Up to a point, yes, because at first we didn't have so much data that would ask for so many attributes, so we were seeing a deficiency there. So we tried adding, and it definitely improved. But you're right that there's definitely a limitation there. And one of the things that we were exploring but we didn't implement is that since most of the attributes or data points that you can extract do not really depend on each other, you can just run in parallel let's say you have 20, you can run 5, 5, 5, and 5. And these would benefit even more from the batch processing and the context reuse, because the context would be the same, right? The HTML. And the only part that will be changing is if you put it in the end of the prompt, the only part that changes would be the attributes. And so you would reuse most of the context. So that's, I think, a way to simplify the problem and giving the most of the technology.
Thank you.
So I would like to ask you back to the model context protocol, to the MCP. If you in few sentences tell us what's the source of your doubts, because I personally became sold today. I got convinced, I'm all in, and now you came. So if you would have a few points.
Yeah, I'm glad you asked that. So the way I think what's going to happen, and this is just speculation from my part, is that we as humans never needed MCPs, right? So we have APIs and we understand them, we read them, we navigate the web, we understand how they work. We try it, it doesn't work. I check documentation. So we figure ourselves how to work with APIs. I kind of understand right now LLMs are not powerful enough to do this kind of process, but I'm pretty sure that they will be at some point. So MCPs are, closing this gap. But this gap, as LLMs become more and more powerful, it will be closed by themselves. So MCPs, it's possible that they will become deprecated when they are allowed to.
I was struggling with the same idea, right? Because basically it's a replacement for documentation. But at the same time, I was going to ChatGPT and ask, what's the protocol, right? And basically protocol is sets of standards. So it's the standardized way how to document API, and that's my final understanding. Yeah, so I agree to some sense, but at the same time, it would be great if Salesforce and Gmail and everything and every API had the same set of standard documentation. Because then you can do the training much better.
Yeah, I agree, but the problem is that it's impossible to everyone agree on something. Companies will rarely agree. This is getting some kind of traction, the MCPs, and that's why companies are trying to build on top of that. But generally, when doing APIs, you just have to, if you try to work with OpenAI API and then Google Gemini API, not the one that is OpenAI based, like their own one, you will see that they're completely different, so they can't agree on that. So I think MCPs are kind of trying to do this, but I am not so sure that adding this kind of indirection layer in the middle will be something that every company will want to maintain, especially if LLMs become capable of just investigating themselves how to use a tool. And just as an analogy, I like to think the humanoid robots that they're building. Why do they do humanoids? Why spend so many billions of dollars doing robots that have human shape and size? Because everything that we have built around us is prepared for us to work as humans. Like a door, you see a door, the size of the door is in a predefined shape and size. So I want to think one of the reasons that why robots are trying to go into that direction. So if you would, for example, make a robot smaller or a box or something, our world is maybe not so prepared. So we have stairs, we have buttons. So I like this analogy translate to MCPs, which is less physical, but it's the same idea, right? Why are we trying to build something to make them capable of doing something that they probably won't need at some point. But that's just my take.
Okay, thank you.
Thanks.
I had one more question about the fine-tuned models. At what point did you realize that you needed a fine-tuned model, and how much data did you actually use to train it?
So I don't think it comes from the fact of needing, when trying an open source model, you definitely need this kind of fine-tuning, because the models are so small and they will fail a lot, especially giving structured output. And even if you try to force them to generate structured output with some kind of library or a grammar, and there are papers that say, and this has been shown, that the quality of the output is much worse because you're playing with the probabilities of the tokens. So when we saw that doing very, very little fine-tuning with 100 examples was enough to boost the quality of the extraction by a lot. And right now, I think we're using 2,000 data points, like examples of input-output prompts to fine-tune our model, and around 300 for validation.
Thank you.
All right, everyone. Thank you very much, Ivan. Let's give him another round of applause. And thank you again for all your questions.